All right, here I have a graphic that we're going to try to use to describe how and why a bacteria might want to use or utilize the lac operon in its genome. Here we have, let's pretend this up here is a sandwich, and we're eating a sandwich, and we're eating it over a glass of milk. So we're eating our sandwich, and while we're eating our sandwich, a crumb falls off the sandwich, and it was part of the bread, of course, and it falls into the milk. So our crumb now has fallen into the milk down here. Well, before, on this crumb, on this piece of bread, there was some bacteria, 1, 10,000, million, whatever. They were on the bread, and of course what they were doing, they were eating things, part of the bread, probably sugars, all right, but they were sugars that you would find in bread, not in milk. There's probably not going to be any lactose in bread, all right. Lactose is a sugar that is found in milk. So while you're eating your sandwich above your glass of milk and the crumb falls in, well, the bacteria suddenly are in a new environment. The bacteria are sitting there in some milk, and now the sugars that were present up here in the bread are not there anymore. Now you have lactose. Lactose is the dominant sugar inside milk. So suddenly you have a bacteria and it's surrounded by lactose. All right, this is going to be, we're going to use this as our designation for lactose here. Little stop there. Just millions of little molecules around the bacteria. Well, that lactose, but the gene normally off. So it's normally off. State. And that's the key to understanding and how does that sense cannot get in to in that shouldn't, and it's just so happens chemical in the environment find a certain number of those molecules are going to turn into a special LLO out of pore. Now at the pore, lactose can sneak in, and that's page to explain what's Terminator. The operator. Operating sequence is right here. Well, that's going to be an important sequence right there. Always occurs immediately. And it also has your standard data. I is the doing the code for a protein attaches to the data. It's instead of being attracted to data, we don't have to know what exactly those sequences to this O sequence. It sticks hard. It can't get past it. The I protein is stuck there. So the function of the of I, well, more or less turn on and off the lack of. I'm getting better at writing on this thing. All right, so with this, we now know how you turn it off. But how do you turn it on? Well, we have a clue from what I just talked about in the previous picture I was drawing. It's allolactose. Allolactose. Well, this chemical, as much as I likes binding to this piece of DNA and binds strongly, allolactose, well, it likes to bind to allolactose better. So if allolactose is present, allolactose will bind to the I protein. And if it does, all right, it will cause a shape change. Just like ATP causes other proteins to change shape, allolactose causes I to change shape. And when it does, when allolactose causes it to change shape, well, it can no longer stick to O. So in the presence of allolactose, I, even though it's made quite regularly, if there's enough allolactose around, it will cause this to fall off. So with these two combined, all right, when this little one binds to the big one, they fall off. And if they fall off, you now have a clean slate. All right, the polymerase combined, and it can move all the way across Z, Y, and A. All right, and your TATA. So it binds, it moves across, you make your stuff, and you end up with your 3 proteins, and everything is working inside the cell to let in the lactose now, to digest it, and to detoxify anything that sneaks in with it. So now you have an idea of how this works. The allolactose, which is always around the lactose, can sneak in when there's a lot of lactose around. It's going to be sneaking in. And when it sneaks in, it's going to attach to the I protein. And the I protein keeps this gene, this operon, off. But when the allolactose is there, it's essentially going to bind to this protein, change its shape, and that new shape cannot bind to the O sequence. So it's going to fall off, and you're going to end up with a functioning operon. And the functioning operon is going to let you digest all that lactose that's now out there. So this is how the operon senses, all right, or the cell, if you want to think of it this way. The operon allows the cell to sense the presence of lactose in the environment. And so when that little breadcrumb fell into the milk, okay, all of the chemistry inside the cell changed in such a way that the allolactose snuck in and turned on the lac-operon, and now that bacteria is real happy. It can sit there and digest all that lactose, turn it into ATP, and actually multiply. They'll grow in there. All right, and this is the end of this one.